For this video, we're going to be discussing imaginary and complex numbers. So to get us started, the first thing we need to do is go back and revisit number systems. So if you remember back to Algebra 1, you should remember dealing with the real number system. And inside of the real number system, we have all these different types of numbers, including the natural numbers. And the natural numbers, if you remember, just the counting numbers like 1, 2, 3, and so on, all those positive numbers. The whole numbers are those same numbers, 1, 2, 3, so on, but they also include 0. Then we've got the integers, and the integers are all of those numbers starting with 0, but the integers also include the negatives, so like -2, -1, 0, and so on. And then we have the rational numbers. And the rational numbers includes all of that stuff. But it also includes fractions and decimals. So like 1/2 or 0.27 or 0.3 repeating or 5 halves or anything, 1.26. Okay, so rational numbers are all of our integers plus all of our decimals. Then we have our irrational numbers, and our irrational numbers are numbers like pi, or non-ending, non-repeating decimals like 0.712643, just numbers that go on forever and never repeat. And if you take the rational numbers and the irrational numbers together, they form the real numbers. Now, what we're going to be talking about in this video are two other types of numbers, complex and imaginary numbers. And complex and imaginary numbers are just other sets of numbers. So imaginary numbers, we'll talk about where these come from in a minute, but imaginary numbers always include the letter I. So like I is an imaginary number. 3i is an imaginary number. I to the third power is an imaginary number, so it's like -2i. Okay, these are all imaginary numbers. Notice they all have this I. And then a complex number is a number that's made up of a real and an imaginary number together, like 3 plus 7i, or 9 minus 6i. Okay, complex numbers always look like this. And as we go through our examples, it'll make more sense how imaginary and complex numbers work. So to get us started, let's first look at imaginary numbers. So if we look at this math problem, we want to start with this problem here, x squared equals -1. All right, so if I wanted to figure out in this problem what x was, I would have to take the square root of both sides. So I'd want to go square root here, square root here. And I'd end up with x over here. And on the other side, if you remember back to Algebra 1, we can't really do square roots of negative numbers. And that kind of presents a problem. So the way that that problem has been solved in math is we take this square root of -1, which is a number we can't define, and we just call that I. And we call that the imaginary unit. So the square root of 1 is known as the imaginary unit, and it's just going to be represented by I. So anytime you see the letter I, it's referring to the square root of -1. And all of the other imaginary numbers are made up of the multiples and powers of I. So all imaginary numbers are made up of multiples and powers of I. So I've got like 2i, I to the third power, -6i, I to the seventh, 4i to the ninth. These are all multiples or powers of I. So when I write 2i, what I really mean is 2 times the square root of -1. When I write I cubed, what I really mean is square root of -1 cubed. Right, that's what these mean. So when I want to talk about the powers of I, we're going to notice that there's actually this pattern to them. So I, that's the square root of -1. If I do I cubed, or I squared, if I think about I squared, if I think about what it means to square a number, I squared is the same thing as the square root of -1 squared. Well, the square root and the squared and squaring, those are inverse operations. So this squared and this square root cancel each other out. So I squared is actually just -1. So I squared is -1. It's kind of weird, but it works out. If I do I cubed, well, I cubed is I squared times I. And I know I squared is -1. And so I'm doing -1 times I, which gets me -I. So I cubed is just equal to -I. So I've got I squared equals -1, I cubed equals -I. And then if I go through and I deal with I to the 4th power, well, I to the 4th power, 4 is 2 plus 2. And if you remember exponent addition, or yeah, if we do exponents, I to the 4th breaks down into I squared times I squared because 2 plus 2 equals 4. So if I look at this, it's I squared times I squared. Well, I know that I squared is -1. So I to the 4th is -1 times -1. Our negatives cancel each other out, and I've just got 1 times 1, which equals, didn't mean to move that around, equals 1. So I to the 4th power is just equal to 1. And these 4 powers of I, so I squared, I cubed, and I to the 4th, are the most important powers, because you're going to see that we can turn any other power of I into one of these. For example, if I look at I to the 5th, I to the 5th is the same thing as I times I to the 4th power. And we know that I, we just leave as I, and I to the 4th we know is 1. And I times 1 is just I. So notice that I to the 5th is the same thing as I. And if I want to continue this pattern out, I could say, well, okay, I know I to the 5th is the same thing as I. And then I to the 6th power is the same thing as I squared, so that's going to be -1. And I to the 7th is going to be the same thing as I cubed, so that's going to be -I. And I to the 8th power is going to be the same thing as I to the 4th, so that's just going to be 1. So if I know these 4 powers of I can figure out any other power of I. So let's talk about how to simplify. So the steps to simplify powers of I work like this. The first thing we're going to do is we're going to split our power into 2 numbers. The largest multiple of 4, and then whatever is left. And then any multiple of, since any multiple of 4 is equal to 1, it just goes away. And then we just simplify whatever our remaining power is. So let's take a look at some examples and how that works. So if I look at, for example, I to the 23rd power. Okay, I to the 23rd. All right, we look at this and we want to go, okay, I to the 23rd. What is the biggest multiple of 4 that's smaller than 23? Well, the biggest multiple of 4 that is smaller than 23 is 20. And then I do 23 minus 20. That's 3. So now I to the 23rd is the same thing as I to the 20th times I to the 3rd. And so when I think about this, I to the 20th, because it's a multiple of 4, is just equal to 1. And I cubed, we know from our powers of I, is equal to -I. So this is just 1 times -I, which is -I. And that is the simplified version of this. So all we do is we split it up into the closest power of 4 and whatever's left, and then we just simplify whatever's left. All right, so we can do the same thing with I to the 31st, or I to the 34th. So if I look at I to the 34th, the biggest multiple of 4 that is less than 34 is I to the 32nd power. And then 34 minus 32 is 2, so that's I squared. I to the 32 is just 1, because it's the same thing as I to the 4th, and I squared is equal to -1. So this is 1 times -1, which is -1. So that is the simplified version of this one. If I look at these two down here, they're a little different because I've added in some stuff. In part C, I've got a coefficient, and in part D, I'm doing some multiplying. But if we look at part C, 3 times I to the 38th power. Well, that's going to be equal to 3 times the biggest multiple of 4 that's less than 38 is 36. Oops. So I to the 36. And 38 minus 36 is 32. So I to the 32nd, or sorry, 38 minus 36 is 2. So that's I squared. So if I simplify these, this is 3. I to the 36 is 1. Any I with a power that's multiple of 4 is just 1. And I squared we know is negative 1. So now I've got 3 times 1 times negative 1, which is negative 3. That's our answer here. For part D, I want to do a couple things. The first thing I need to do is multiply. And if you remember how to multiply numbers with exponents, you want to multiply your coefficients. So 5 times 2 is 10. And then to multiply your exponents, you just add them. 19 plus 5 is 24. Now, if I go to figure this out, to simplify this, that's 10 times I to the 24th. Well, 24 is a multiple of 4, so I to the 24th is just equal to 1. So this ends up being 10 times 1, which is just 10. So that's how we simplify a power of I. All right, we split it up into the biggest multiple of 4 and whatever is left. The multiple of 4 is just 1, and then we simplify whatever is left. So now this brings us to talk about complex numbers. So complex numbers are the biggest set of numbers that we're going to deal with, and every complex number is made up of a real number and an imaginary number put together. All right, so the format is always going to look like this: A plus BI, where A is just a number and B is just a number, and then we've got I. So a complex number could be like 3 plus 2I, or 9 minus 6I, or like 12 plus 15I. They're always going to look like this. We can't write them as decimals or anything because of the I at the end, so we just have to write them in this method with an integer part and an imaginary part. So what we want to talk about is how to do some operations here. So first we're going to talk about adding and subtracting complex numbers. So to add or subtract complex numbers, all you have to do is simply combine your like terms. So if I take a look at this one, right, to combine my like terms, the first thing I want to do is I can just rearrange these. So I've got 3 plus 5I plus 9 plus 2I. One thing I can do is just rearrange them so that my two integer parts, 3 and 9, are together, and my two imaginary parts, 5I and 2I, are together. And then I just simplify. 3 plus 9 is 12, and 5I minus 2I, 5 minus 2 is 3. So this works out to be 12 plus 3I. So combining like term, or adding, subtracting, no big deal. We just combine our like terms. So if we take a look at an example here, okay, I've got 4 plus 6I minus 2 plus 11I plus 1 plus 2I. So what I'm going to do is I'm going to just rearrange these things. Okay, one thing I'm making sure to do is, since this is minus, this becomes a negative 2 and this becomes a negative 11I. Got to distribute out that negative symbol. And then I just rearrange things so that my integer terms are together and my imaginary terms are together. And then I just work it out. So 4 minus 2 plus 1, 4 minus 2, that's 2, plus 1, that's 3. 6 minus 11 plus 2, 6 minus 11 is negative 5, plus 2 is negative 3. So this becomes 3 minus 3I. So that's all we're doing, combining like terms. Now we also need to know how to multiply complex numbers. So to multiply complex numbers, the first thing we're going to do is we're going to distribute twice, and then we're going to combine our like terms. So let's take a look at this. So the distributing twice, what that means is I'm going to take this 5 and multiply it by both the 8 and the negative 4. And then I'm going to take this 7i and I'm going to multiply that by the 8 and the negative 4. So if I work that out, 5 times 8 is 40. 7i times 8 is 56i. 7i, and then I want to do the same thing over here. So 5 times negative 4i, 5 times negative 4 is negative 20. I've got my I. 7i times negative 4i. 7 times negative 4 is negative 28, and I times I is I squared. So now I've got this to work with. I want to do some simplifying. The first thing I want to do is I want to look at this I squared. We know that I squared is equal to negative 1, so I want to turn that into negative 1. So if I rearrange these, negative 28 times negative 1 is plus 28, positive 28. And then I just rearrange the rest of them, and now I just combine my like terms. 40 plus 28 is 68, and 56 minus 20 is 36i. And this is my answer here. So let's do one more example together. So if I take a look at this one, okay, my first step, okay, so to do this problem is to distribute 2 times 7, 2 times negative 6i, also 4i times 7, and 4i times negative 6i. When I do that, I end up with this expression here. 2 times 7 is 14, 4i times 7 is 28i, 4i times negative 6i, 2 times negative 6i is negative 12i, and 4i times negative 6i is negative 24i squared. This negative 24i squared, 24 times I squared, we know I squared is negative 1, so that gives me negative 24. So minus a negative is the same thing as plus 24. So then I can rearrange all of this stuff. Over here I've just got my plus 3i. So I get all my integer stuff together, 14 plus 24 plus 3. All my imaginary stuff together, 28i minus 12i plus I. And then I work them out. 14 plus 24, that's 28, plus 3, or 38, plus 3 is 41. 28i minus 12i is 16i, plus 1i is 17i. And there we go, that's what we've got. So, hopefully from watching this video you understand what complex and imaginary numbers are, and how to simplify them, and how to add and subtract and multiply complex numbers. So I'm going to leave you with this try it problem. You need to simplify 3i to the 23rd power and 5 plus 4i times 6 minus 2i.